Hello, Chad. How are you?
I'm good. A
Good, good.
little smoky, but other than that, I'm doing fine.
Yeah, yeah, a little crazy up there. Well, good. Welcome, everybody, to another Wednesday live streaming. Today, we're going to be addressing a lot of getting started questions. So, we'll feel free to put your questions in the chat, but we have a couple questions that we'll start off with. But yeah, the ideas here is to just go over a lot of the basics. Talk about you know a lot of common questions that we get when people are getting started with Docker around what's an image, what's a container, what's a VM, those type of things. So yeah, I guess we can just jump right into it. Let me pull up the list of questions that I have. But here's a great one. We get this a lot, especially some of the changes with WS2 and those type of things. But so, Chad, can I run Docker on Windows?
Yeah, turns out you can. There's that question gets loaded because because of Windows nowadays is can mean a lot of different things. So one of the things it can mean is can I run Linux containers on Windows? And one of them is can I run Windows containers, which is a completely different but similar beast. So the answer is yes, you can do both. I'm actually on Windows now, so let me actually share my desktop, and I'll share some stuff. Um, so this is Windows, like it has Windows, and in this is also uh, Linux. And make this bigger so folks can see it. Make it really big so folks can really see it. Actually, I'll just switch to the CLI now because we all know that
We're in
I'm
Windows.
not doing any
You're
magic.
not faking it,
It's
right?
actually um
It's not
and
fake
so
news. No fake news here.
this is a Linux kernel running in Windows under WSL2. And there's Docker in here. Oh, hold on one second. I need to fix this. So I just rebooted my computer and I need to start Docker. I go to, actually, I'll show you.
Yeah, but
Let's
yeah,
go
cool.
back to desktop. So, Docker is a service that's down here. And I can say, I'm running Docker desktop and I'm going to ask to restart Docker. The way that I got Docker was I went and I grabbed a browser and I said, well, how would I get Docker top for Windows? And I would go to here, Docker Hub, release. I picked Edge as being on the Edge, and I also testing the new we have with Soft. The Edge release. You can use the stable release, and download that. And then once you have it, we'll go back to the terminal. You can install it, and you'll get Docker. And so you can do all the normal things that you would think to do. So you could just run Redis, and in the end, it's just Docker. So it's kind of tricky, or it's not tricky. It's a little inception-y. So I'm running Windows, which is running a full virtual machine of Linux, which is running Docker inside of that. And so, yeah, it kind of blows my mind, but it works super well. I've been running on this desktop basically since work from home started, and I have a Mac laptop that is my Docker laptop. But since work from home, I have this really nice desktop with nice big monitors and tons of memory and like 12 or 16 cores, I can't remember. And so it's like, well, why would I use a little laptop when I've got a big desktop? So I've had Docker on this, and I've only used this. And I run Windows as my daily driver. And I don't use command and I don't use PowerShell. I just use Linux and Docker all day. And yeah, it just so happens that I can also fire up, games
I
or
was gonna
other
say
things.
all your awesome games, right?
Yeah, awesome games are in my life probably more like PowerPoint. But so yes, you can do it, and you can also run Windows containers. We don't see it as often, and we see a lot of folks on the Windows side moving towards Linux containers because they're just easier. But you can do it. Actually, even within Docker Desktop, you can do it. So if we go back to the desktop, you can. Let me go find the. Let's see. You can switch to Windows containers, and Windows containers are in the same family as Linux containers, but they're different, right? The operating systems are different. Um, like notionally, how those containers work is the same, but it's just a different technology under the hood. So it's definitely one of those things that you kind of need to know what you're doing for Windows containers. Not that you don't need to know what you're doing for Linux containers, but yeah, I generally recommend people run the Linux container side unless you really have like one of the needs for like the nano server or one of the other images that you just can't replicate over in Linux land. But yeah, you can run Windows.
Yeah. Okay, here's a great one. So Santosh just asked in chat, when can we expect Windows containers to run on Linux? You want to tackle
Uh,
that one?
so there was this like LCOW, right? So it was the other way, Linux containers on Windows. But with WSL2, that's sort of, I think, uh, I would use the acronym OBE, overtaken by events. Like LCOW was a great idea, and then WSL2, the implementation came along and is just much better. And so I think that the flip side, you know, emulating Windows in Linux is tough. So I don't actually know if anybody's working on emulating Windows on Linux. I mean, there are things like programs to do that, but I don't know that anyone's going the other way. Like Windows Server is so rock solid that I think if you want to run,
Yeah.
Windows containers, you should run those in Hyper-V or on a Hyper-V Windows Server box, because that's going to be the most stable place to run those things, for sure.
Yeah, I would agree. It's like you said, running Linux containers on Windows are awesome, but going the other way, a little tricky. Okay, we got one more. Let's see. I haven't read this, but okay, if you're running an app like WordPress, should the app be able to run updates on the plugin code in a volume and on a database that way?
Yeah, so that's a great question for things that are like that. Yeah, exactly, like plugins. So how do you want to do that? So the Docker way would be to have a word you put your plugins in as building that image. And to update those plugins, you would build a new image and roll that out over your other one. But that doesn't always work, especially some of these frameworks can like download their own images. So now you get into this kind of, one of the powers of Docker is that the container or the container should be immutable so that you can just rinse and repeat those deployments. If you can't do that because the container changed the day that you started it to the day that that maybe plugins update, then that just becomes a challenge that you have to figure out how you want to tackle. So what I would probably do is one of two things. I would either hold the plugins in a volume and then only reattach to that volume with the plugins there, or I would bake the plugins into the image. And the risk there is if the volume goes away, you're going to have to you'll have to figure out how to repeat that and get all the right versions of the plugins. And so that's the danger. For databases, that's the same thing. So let's say that you migrate your schema from one to another, and you're using a volume for your storage. that's something that, just bringing up a new copy of the database might not be able to fix for you. And so things that have persistence in Docker sometimes are tough. And so there are lots of different strategies for how to tackle that. But like for WordPress for a developer, what I would probably do is I just wouldn't care about it. I would just go and then consider it all something that you can burn down. And then when you go to deployment, I would consider WordPress plus like one of the, like, either you could use a container if it's like small, or you would use like a managed service for the database side. So like an RDS or something.
Yeah.
So that you can have the local development experience with a local container for the database. But when you go to prod, you put that into something that has a little bit more management about it. Your data is the most important thing, and it's the hardest thing that you might lose.
Yeah, I would agree. Awesome. Okay, here's a great one too. So any specific reason why doesn't Windows 10 Home support Docker? It's a loaded question for you. Softball you on.
It's like a softball. So we just announced support. So a couple months ago, we announced support for Windows Home. I think it's 2004. And then let's go find the blog post. Actually, let's go. So let's go to Docker blog. A great place to find stuff just like this. So we just announced that as part of Microsoft backporting WSL2 to Windows Home 1903 and 1909, in addition to 2004. So we added support for Home 2004 last couple months. Just the other day, on August 20th, Microsoft backported that to 1903 and 1909. And so that means that Docker Desktop works on Home as long as you're on 1903, 1909, or 2004. The trick for the older versions, the 19 versions, is you need the Edge version. So we always put things into Edge first, so they can stabilize and we can make sure everything's up and running and good. And then we'll roll them into stable in like a month or a little bit longer, depending on how long it takes to stabilize. So go get the Edge version, which we just showed earlier on how to grab Edge, and you'll be up and running on Windows Home.
Awesome.
And so Abdullah's right. The reason that we couldn't do it originally was because Windows Home doesn't ship with Hyper-V. And once Microsoft added WSL2, we were able to do it. So on Windows Home, you don't have an option between WSL2 and Hyper-V. You only have WSL2. But I think WSL2 is the better of the two technologies anyway. So, let's just call it a win. Thanks, Microsoft.
Awesome. Yeah, cool. All right, let's see. Here's a good one. And I get this asked all the time, and it's becoming a little bit more not as common, but what's the difference between virtual machines and containers? When we used to, virtual machines are very, very popular, but definitely went from bare metal to virtual machines, and then containers came along. And that was definitely a question I got all the time, right? What's your thoughts on that?
Let's go find some pictures. Let me go back to the web, and let's just let's go find some.
Here, I got one right here. Really good from our. Okay, can you see that, Chad?
I can see it. So it's, which one is it? It's containers and virtual machines.
I'm biased to this picture because it's in our docs.
Let's see. Which one? Let's see.
Go.
Let's just look at.
Go in the docs.
It's this one.
Yeah, it's that one. Yep. Uh-oh. Did you freeze? Did I lose you, Chad? Okay. Well, while Chad's coming back, let me I'll pick this one up. So here in the docs page, we have a section in our getting started.
Are we having issues?
Oh, looks like you're back.
I'm
okay,
back.
Cool.
Yeah, Skype is bouncing. So what do I search for?
Here,
in docs.
Just go to docs.docker.com/get-started.
Oh, perfect.
And then scroll down a bit and you'll see it.
Oh, look at that, huh?
Look at that handsome devil. Right. Boom.
Okay.
There you go.
So this is a great picture. I agree. On the right, we have a virtual machine. So this little devil. And on the left, we've got containers. And there's a couple of key pieces that are different. And so what you'll notice here is there's a hypervisor here. And then the OS, and then some amount of libraries and application. And that line gets drawn slightly different over on Docker, where there is the host OS, a thin layer for Docker, and then the containers in their own little box. And so one of the things that's different is what's in the box. So what's in a Docker container is the application and its dependencies. What's in a VM is an entire operating system. And that's a big difference. And a lot of people think like, well, I use Ubuntu as my base image, so or I use Debian Stretch as my base image, so isn't there an operating system in my container? And the answer is there is a file system from an operating system in your container, but what's actually in your container is just an application. When that runs, most of that Debian or Ubuntu isn't used. It just sits there. Whereas in a VM, you need that full OS because what the hypervisor is providing you is a virtual network and a virtual CPU and virtualized memory. What Docker is providing you is just access to not an operating system's resources directly. So it changes where the virtualization happens. So what does that mean? Well, it typically means that Docker is a lighter weight abstraction. So whereas on this picture, there's 3 guest OSs, each of those guest OSs take a certain amount of resources. So if you're running 3 copies of Linux, that each one of those has some couple hundred megs of RAM and some section of a CPU dedicated to just keeping that operating system going. Over in container land, there's just one operating system, so you get some of that back. That's maybe that's 10 to 30% of your total resources. It's also a lot less to patch. So in the VM land, you've got all those operating systems to patch. And that tends to be lighter weight to roll out. So containers tend to be smaller. I think that you can certainly take snapshots of virtual machines and deploy them in a somewhat similar way, but it's just not nearly as easy as Docker. And so I think those are the big pieces. And also building them is a lot easier.
Yeah.
So I think those are the big pieces. But the most important thing to know about a Docker container is the only thing you really need in there is your application and its dependencies. And the reason that most people use things like Ubuntu isn't because you need an operating system, it's because they want the package manager so that it's easy to install application dependencies. So I want Nginx, and I don't want to have to go to get a tarball and pull that down and then try to figure out all of the different libraries I might need and build that thing from scratch. I'll just reuse Ubuntu or Debian's package infrastructure or Alpine's package infrastructure and take advantage of that.
Yeah. Yeah. No.
And I think that's the
no
big
running
difference.
make and fixing errors and
nobody wants to build things by hand. It's no fun.
Yeah, I think the big way I look at it, at least simplifies in my mind, and this isn't 100% true, but it's a good way to think about it, is that VMs virtualize the hardware. So when you run an OS inside of a VM, that OS thinks it's the only OS on that hardware, right? It has, so you're able to virtualize the hardware and have multiple OSs run on it. And then with containers, you're able to virtualize, I'm going to put that in air quotes, virtualize the OS. So now your applications run inside of the OS, and they think they're the only one there. Like I said, it's not exactly a one-to-one, and that's why you can't run Windows. You can't run applications that were compiled for Windows on Linux containers because the OS is not there, right? So the containers need the underlying OS. And so that's one of the big differences. But to Chad's point, that makes it, you get all those awesome benefits that he just talked about, right? Easy to spin up containers, sharing resources at a higher level.
Yep.
Awesome.
So actually, let's show a little bit of that. So I just started up a Redis real quick, and I'm going to use Docker Desktop's UI to sort of play around with that Redis. So here's the same logs that are in my terminal, and I'm going to ask for a CLI for this. And so this just dropped me into a CLI inside of that container. Let's see. This is super tiny. Let's see if I can make this larger.
Yeah.
But, oops. Oh, PS isn't found. So this is interesting. One of the things about going inside some of these containers is that you don't necessarily have everything you would expect. So I was expecting to find PS, but the utilities are not here. And that's actually a great security feature, it turns out.
Yeah.
Not a great usability feature sometimes, but it's a great security feature. So if you don't need a shell in your container, don't put one in. And then if an attacker was to gain access and they didn't have a shell, they wouldn't be able to go anywhere. So if you don't need something in a container, don't put it in. You can always get it in later if you really need it to debug something. Like I was going to debug this and just show you that this is PID 1. But we can do something else. So let me pick a different container. And next. Yeah. So let's do.
Yeah, that's kind of. It's also, that concept right between the VM and just containers. Containers just a process, right? So I get a lot asked, how do I SSH into my container? How do I remote into my container? Connect. You can execute inside a container, but you have to think of it a little different, right? You're not connecting to a full operating system when you're using containers, right? You're not going to remote into it very much, right? You're thinking it's a process that's running, and if it's just a process that runs to completion, that container goes away. Or if it's a long-running process like Nginx or a node server, right, then that stays around, but it's just that one process. So it's a little different paradigm when you think about containers than between VMs.
Yep. So Skype is not our friend today.
Is it?
Do Docker. I'll make this Docker exec. I want an interactive shell. I'm going to exec to.
And when I was talking there, so you fired up an Nginx container?
Yes.
Okay. Cool.
Did. So let's go see Docker PS. I'm going to do Docker exec. I'm going to do interactive. I want to get into this container, and I want shell ones. Oh, it doesn't have it either. Wow.
Yeah.
That's crazy. I would have guessed that these things had it. But what we would normally show you, if I picked a container that had PS
live TV,
is that Nginx is running as PID 1. And so for those of you who might not be as familiar with Linux, like PID 1 tends to be the operating system. It's the original application, right? So process ID, whatever thing starts first gets PID 1, and everything else gets an ID after that because everybody is a child of something. So when Linux starts up, it has effectively a init or systemd or whatever, and that's the first thing to start. and then everything will come from a child of that thing. In this case, PID1 is Redis, or it's Nginx. So those are Linux applications, and if they were sentient, they'd look around and they wouldn't see anybody else there because they're the only thing that they can see. And that's really the power of like containers themselves, which isn't unique to Docker. Like Linux containers, we're actually just reusing primitives already in the Linux operating system, C groups and namespaces to draw these boxes around. But it's sort of the magic of how you keep those things isolated.
Yeah, cool. Okay, this is another good one. So what's the difference between an image and a container? I love this one.
Good question. That's a good one.
Yeah. Don't go too deep, chat. But we should sorry for a little sidebar here. We should do a live YouTube on creating a container from scratch, right? And setting up the file system and all that type of stuff.
Sure.
That'd be cool.
That'd be cool. Okay.
Yeah. Okay, what's the difference between an image and a container? And I add, unfortunately, I'm trying to do better, right? But on the internets or when I speak, I'll interchange those a lot of times, right? I'll say, oh, let's run our container, let's run our image, let's stop our image, let's stop our container, right? So I'm trying to be a little more precise in my language, but yeah, it can get confusing.
An image is basically just a tarball, or a bunch of tarballs, and so it's just files, and they just sit, and there's nothing special about them. It's think of them like a zip file.
Yeah.
A container is taking those tarballs and actually breathing quote unquote life into it, right? So,
wait, what did you say? What kind of life? What'd you say?
Just actually breathing life into a a file.
Okay, cool.
Okay. So the image is the application at rest. It's like an RPM, or it's a zip file, or whatever. It's just bits on a disk, and then the container is taking that and actually executing it. And it's the running environment. It's the memory being consumed. It's the CPU being consumed. It's the network attached to that application, and that application actually running and being, in an operating system and actually going. And so an image is just files, and the container is actually the thing that's running.
Yeah.
But you get containers from running images, just the same way that you would. You could run a binary on if you go type user local bin Docker. That's a binary sitting on a disk that's not doing anything, and when you run it, you execute it, and that becomes a real thing that does work on your behalf.
Yeah, cool. Yeah, I think of it, if I go back to my old computer science days when I was learning object-oriented programming. You have classes, and then you have instances. So you have a class when you're that's just that template. It says, oh, this is the methods and functions and properties you have on a bundle of code, so to speak. But it doesn't really do anything until you actually execute it, and then you create an instance of those, multiple copies of that class, right? And same kind of concept with images and containers. Is an image you have, is your template, like Chad was saying. It's the file system that your process needs to execute. And then a container fires that up and puts it all in a nice box and uses change root and C groups and some other stuffs. Makes that super easy, right? And you can do that multiple times. So you can have multiple instances of your image that we call containers.
And you can stamp them out. That's exactly. And actually, that leads to the next part of the magic of Docker, which is it's portable. You can take that image, and I can take it from my laptop and put it on Peter's, and now he has it. So now not only do we both have it, but we both have the exact same thing. And so when we Docker run those images, we have everything that we needed, and there's not, this worked on my laptop, didn't work on his.
Yeah, it's like picking up a section of my laptop of your laptop and sending it to me, or and place it back down. Yeah, cool. Cool. Awesome. We got a Docker EE question. Do I delete it?
Saw it.
No.
No, I
I
saw it.
just did you see that,
So
Chad? Yeah.
yeah, we're going to go into history now. So Docker EE was Docker Enterprise Edition back when Docker had an enterprise business. That business split off. I don't even remember how long ago, but maybe a year. I
Coming
don't
up on a year,
remember.
I think. Yeah. Yeah.
Yeah, and went to Mirantis. And so what that is what EE is basically an enterprise version of Docker, and with support and all of those pieces. So Docker Inc. doesn't have that anymore. Mirantis has Docker EE, and Docker EE is just Docker. It's just a version that is supported for longer and supported by an entity, so that if you have something go wrong with it, you can call them. And so that entity is now Mirantis, and you can go chat with those folks. There's nothing special about it. It's Docker. So that'll work for you.
Oh, did you see that one? Should we come back to the firewall question?
We can talk about
Let's
it. I'm happy to talk about it. That's a great
yeah,
one.
cool. Thanks, Manish.
So Manish, by default, we take care of that for you. We don't. Docker doesn't expose any ports for a container out of the box. When you hit Docker run, it's up to you to decide to expose ports. So you can think of it as a firewall, but really, what it is that we don't allow any outgoing network without you saying that's what you want. So if we go back to the CLI and I run Nginx again, and I go to Docker PS and I find that Nginx, it's got port 80, but that's not exposed anymore. Oops, sorry, you can't see that. Let me go to the CLI. That Nginx has port 80, but there's nowhere to go find it. So if I go to localhost port 80, I'm going to just bounce because there's nothing there. Now, if I run this again and say, hey, go ahead and expose on 8080 port 80, we're going to run that again. And we will go to localhost 80, and we'll have Nginx. So it's not quite a it is a firewall-like behavior, but it is not a firewall. It's a very specific network. You decide what happens, and you decide what ports are exposed. You decide what that looks like. And in Docker, you have a lot of functionality for like which network do you want to use. You can use the host network. So let's look at. Let me think how I can. Let's see. So there's a couple of networks. There's a bridge in here, which is what by default most people do. There's host, there's none, and then you'll see that there's a couple of extras. So bridge is a natted network where like Docker has its own network. It has containers on that network, and it nats them across and just takes care of it so that you can see the internet and you don't have to worry about it. Host takes the network interface in the container and basically just attaches it to the host network. And so if you said 80, normally 80 would only be available sort of like localhost. If you said 80 on host, then anybody that can see port 80 on your laptop or desktop would be able to see all of that. And then there's also none. So if you've got a container that doesn't need to see the world, one of the safest things you can do is say, hey, run this in the none network, and then it will have no network attached, and there will be no one that can talk to it except for you. You'll also notice that I've got a couple of extra bridges that are Minecraft and Docker ECS. What those are is Compose creates a network for each Compose file that you run, so that those containers are isolated. So you can create a bridge for a group of containers, and then they can see each other, but other containers can't see them. So we don't have Firewall in sort of the Linuxy sense, and you don't need to run a firewall inside of your container because it's not an operating system. It's a application. So you can let the Linux host run the firewall, and you can decide what comes through that firewall. And maybe you want things to talk to the containers, and maybe you don't. But the containers themselves, you just decide what port you want to expose and on which network.
Awesome. I was gonna. We don't want to go down the overlay. Let's not go too deep into network. All right, we'll stay there. But this one's kind of in the same germane, I guess, as that question. So, what's the difference between Docker and Kubernetes? I get that a lot, right? That's
Sure.
hopefully as opposed to like images and containers, I confuse or probably add to the problem of mixing those terms. But definitely Docker and Kubernetes, I get asked that a lot, right? And I think there's a lot of confusion out there. I've been asked why would I use Docker? I'll just use Kubernetes, or why use Docker? Just use Kubernetes, right? Like I get that question a lot, right? Yeah.
So Kubernetes is an orchestrator for containers, which means an orchestrator is, if you think about in a symphony, there's somebody up front with a little stick that's telling folks what to do. And that's really what Kubernetes is. Hey, I want these servers to run these containers at these versions and make sure that they're always running. Okay, now please stop doing that. Or I want on these servers this other application. Okay, now make 2 copies, one the old, one the new. Now take away the old. And somebody is directing traffic or directing the orchestra what to do, and that's Kubernetes. Docker is a technology that lets you build and run containers, but it doesn't do that across a bunch of hosts, right? Like, I want to run a container. Great, you can run it locally. You can build it. I can push it to a hub. I can do those things. But it's really, at least up until recently, it's been focused about one host, right? So most people don't run Kubernetes on their laptop. They run Docker. And Docker helps them get through their day, get their work done, work their inner loop. Those images, not containers, those images get pushed to a registry. And then potentially in production, they go into a Kubernetes cluster. But those are Docker images going into a Kubernetes cluster to be run as containers. Kubernetes doesn't actually know how to run containers. It uses a technology underneath to run containers. One of those options is Docker. One of those options is a technology called Containerd. Turns out Docker also doesn't know how to run containers on an operating system. It uses Containerd to run containers on an operating system. So, it's a little bit about, is it multi-host? Are you orchestrating something? Are you just doing something? But when you use Kubernetes, you are effectively running Docker containers in a different orchestrator. And that's it. You could also run Docker containers in ECS, which is Amazon's Elastic Container Service. You could also run Docker containers in Azure Container Instances or Azure ACI. Those are both orchestrators. Their job is to sort of pull the strings on containers and make sure that they're running, and where do they run, and do they run on one host or multiple hosts? And that's the job of an orchestrator. And Docker is the technology that builds images and calls out to Containerd to run them. Most people use Docker on like end user or in a world where they don't have an orchestrator. So like a Docker engine running in an EC2 instance and something else is orchestrating. So you've got Puppet or Salt or something else. Or there's some people that still run Kubernetes on top of Docker, and that's another option. But yeah, that's really what Kubernetes is. It's an orchestrator for containers.
Cool. Yeah. Yeah, it can get confusing at first, for sure. I know when I had the same confusion. Wait a minute, Kubernetes, Docker, what's the difference? Are they different things? Are they the same? Are they not? Cool. Okay, so I'm reading down. So we had a question. Let me try and manage Windows here. Okay, there it is. Deval. So he's having issues running Docker Compose on Windows Server 2019. Taking a long time to run Linux containers. I asked you in the chat there, it could be, if you can give us maybe a more specific question or maybe give us a little more details around it. It's hard to help. That's something we would probably have to help troubleshoot or look at some of your configuration and, your compose file and those type of things. So, but you're not missing something. I would say there's nothing special, right, that you need to do, right, Chad? I wouldn't say, make sure you flip this bit.
The things
right?
the things that can take a long time, right? So just general resources on the box. Also, pulling tends to be the thing that can take a really long time, depending on where the image is hosted and how large the image is. I think a lot of folks, for example, if your image is 5 gigs and you're pulling it from sort of the western United States into the eastern United States, you have to move 5 gigs across the country, and that just can take a while depending on your internet. So that's one that can cause or feel like slow. But yeah, there's a bunch of things that can cause slow. There's a great question. So Manish, we're gonna have to do this deep dive with like how do you build a container from scratch and talk about these things.
Yeah.
So Manish asked a question about run C. So run C is what containerd uses to run containers. So Docker uses containerd, which uses run C, which actually runs containers.
It's like,
and so that's a
containerd is like a little mini orchestrator inside of. Is that horrible? Is that a bad analogy? Hopefully I didn't mess that. That's the way I kind of.
I mean, it's good enough, right?
Yeah.
Like, and we'll bring on one of the Docker engineers who can talk about like why those things are architected the way they are. So they, it's architected that way for operability and upgradability and a bunch of other things. And that is definitely not my strong suit on the how does it all work and magic.
Yeah,
but it's a great question that we'll have to do a deep dive, and we'll go get an engineer and drag them on and get them to tell us all about it.
Yeah, cool. There's let me grab this next question and I'll try and find. Well, no, we'll save it for that show. I was gonna say there's a great video out there, but we'll save it. That's a cliffhanger. Okay, let's see. Okay, let's talk about. There's a couple here, Chad. So we could talk about build X and build. What's the difference there? And then maybe some compose. What's the difference between Docker and compose and why? Let's do the compose one first. That sounds good, right? Because you usually start out, you're building your Docker file, you're writing your Docker file, building your image, then running your container. And then you start going, okay, well, I need one container for this service that I need while I build my application. Oh, well, I need a database, right? And I have Mongo running locally or MySQL installed on my development machine, running natively on the machine. And now I'm switching to another project and I have data and man, that's good. Okay, so I'm going to run that in a container, right? And you start getting multiple containers running, building multiple images. So that's kind of where Compose comes in. So yeah, maybe Chad, explain to us what's the difference between.
I have a really good example.
Okay,
here.
awesome. Let me.
It's Minecraft.
Let me switch the. Let me. Okay, cool. There we go. You're full sharing now.
Yep. So my example is going to be Minecraft. Um, so we wrote a blog post about this the other day. You can go to blog.docker.com and read Guillaume's post all about it. Um, and it's really simple. So I can run Minecraft doing Docker run. So I can do Docker run. I forget. Yeah, yeah. So Minecraft server latest, right? Except there's a couple of things. It's not actually that easy. I need to do an environment variable to accept the EULA. I need a volume because I would like to persist my Minecraft world across reboots. And I could type a bunch of volume stuff here. I also need, I need to do some memory so that I can set some memory bits. And then what ends up happening is I have this really long command. And this is just for the one container example. There's lots of multi-container examples like you were talking about, but this is just the one. A lot of people ask me, why would you use compose for one container? So let's look at the Docker compose for that locally for one container. And what we see is like, I've got an image. I also want to expose the port. I want to set the restart policy to always. That's 3 flags that I would have had to pass. Then I want to set 3 environment variables, a EULA, a message of the day, a seed, and a memory limit. That's 4 more flags you'd have to pass to run. This actually doesn't matter for a local. That matters for the one that I'm going to show you next. And then a volume. I want a volume for Minecraft and attach it to data. So that's like 7 or 8 command flags that I would have to remember, put in the right places, and that's a pain. Or I could just put them into this file and then type docker compose file. And it's going to go get my Minecraft server up and running. And I didn't have to type a bunch of stuff, and I don't have to remember that.
Yeah. And
so that's one reason why people it's I don't want to say it's a scripting language, but it's a language container looks like when it's running.
Yeah.
So I want you to use this image, these ports, these volumes, these environment variables, these pieces and parts. And then, potentially, I want you to compose several containers together into an application. So A talks to B, and B talks to C, and C just happens to be a database. It also lets you do cool stuff like this. Let's see, let's go ahead and stop this. So that was that version. And this is the version to take this to, let's get rid of this. To take this to Azure and run this in Azure. And so I'm going to take that exact same application and run it in Azure. And I want to also say 1 CPU and 4 gigs of memory. I want a volume, and I want that volume to be in Azure and stored in Azure. And so we can do that as well. Now let's go look at a multi-stage, or not a multi-stage, a
and as you're pulling that up, before I got smart, I used to do this all in shells in bash scripts.
And that's a lot of folks still do, right? They write a bash script, and that becomes something that they have to maintain, and they have to get everything working. Or you could just write a simpler, in my opinion, the simpler ways to use compose.
Oh yeah, yeah.
So here's a version that has 2 services, a front end and a back end. That back end just happens to be Alpine, not Alpine, Redis, using Alpine. And the front end is there's an image, it exposes some ports. It depends on the back end, so make sure the back end is up before you try to start the front end. And it uses a secret. In this case, we're using a secret to set a password between the user of Alpine, the user of Redis and Redis, so that Redis can have a secure connection and you password protect your Redis database. And so you need a password for that. And so you can define all of this in Compose. So Compose is a way to effectively script what your Docker run looks like. And it's a way to define what your applications are and how they work together.
Yeah.
I think that's an easy way to put it.
Yeah. Yeah, it's awesome. Perfect. Yeah, cool. Yeah, I remember having bash scripts and then trying to change, you have to goof, then you start formatting all your flags or options to your Docker run command, and then you fat finger them. It's just, and this, to me, it makes it so much easier. It's all there logically, right? You can read down exactly what you're doing. Trying to read that all in one command is a pain, right? So if I give it to other developers, it just looks like a big, huge 3-wrapped command. But once it's in a compose file, you share that compose file nice and easily with your other teammates. Awesome. Looks like we got we got a couple minutes here.
Yeah. So I'm gonna ask. So hi, Omer. It's good to see you. I'm gonna answer your question. I don't always play favorites, but people who show up to just about every single video stream that we do, I'll put you in front of the line for this one. This is also a great topical question. So what I think you're asking, Omer, is if you set up a cache, so a Docker Hub image cache, and you set that up sort of in your local environment, how can you configure your Docker client to use that cache, and do you have to do anything special? It's a topical topic. Lots of people are looking into deploying caches today, or not today, but in the last couple of weeks. For those of you who don't know, what we're talking about is using Docker Registry as a pull-through cache so that you can cache hub images locally. And so what that would let you do is, for example, at my house, I've got a Synology, which is a little NAS that runs Docker, that has a copy. It's running a copy of the registry, Docker Registry, as a pull-through cache. So I've got these 5 or 6 Raspberry Pis behind me. I've got this desktop. I've got 5 or 6 other servers in this house that all run Docker. And I don't want to go to Hub every single time I want to pull Ubuntu or Redis, which if you've seen my videos, I pull Redis basically all the time. And so what I can do is I can set up a registry locally, point my client to use that registry. It'll go pull. It'll save a copy of that pull and cache it for later. And so when I go ask again, it'll check the cache first. If it has it, it will just give it to me from the cache. If it doesn't have it, it'll go to Hub, pull it, and then cache it for later so that it builds up a cache of images. And so it's a great way to cut your egress if you're paying for the bandwidth, or it's a great way to have a faster. Usually your home network is going to be faster, or certainly your data center network will be faster. So then, what do you do once you have that? Well, let's go look at my desktop real quick. I'm going to go to Docker. I'm going to go to Settings, and I'm going to set the Docker engine. So this is kind of so small. I can't make it too much bigger, but in here there is a setting for registry mirrors. And I've got HTTPS docker.chadmetcalf.com port 8443, and that's where my cache is hosted. That's on a Synology box that's running inside of my local network, and so my Docker client will use that. Let's get out of here. So let me see. I don't know how to. I'll go to one of my Pi servers. And let's go look at this is the same thing. So I've got this Pi server. It's set up to use a registry mirror. It's actually, this is a good thing for me to fix. It's actually using the wrong port. So let's do sudo vi, and we'll update this to 8443. I just recently enabled HTTPS on this. So it was just running sort of without TLS, and now I've added TLS. Oh man, I'm so bad at this. For those of you who can't tell, I do not run system D things in my old days. So restart service. Yeah. So what I just did is I switched that registry mirror to point to the one that's actually working. And once that gets done restarting, then I'll have a mirror of Hub, and I'm running that on my Synology. You can run it on basically anything that runs Docker. So that's Docker run registry, and it's root 2. Let's go to, actually, we'll go to the web. Let's do registry. So Docker registry has a pull through cache. Here is the docs for it. And so you can see how this works. Basically, you're going to add a little stanza to your registry config with a proxy line for registry 1, which is Docker Hub. If you have, I would use a pat, not the password, but you can put that in here, and then you can also cache your Docker Hub private images, and that will give you a much faster experience. I don't know if I can demo that. I guess I could if I thought of an image that I've never run. So let me go, and I have to think of an image that I've never run ever I got one. MariaDB. I've never run MariaDB. So let's see.
And why would you?
How?
No, I'm just kidding.
Let's see how long this takes. So you'll see that, yeah, it's going kind of slow. I don't have a good way to test how long this takes, but I'll show you what at least the percepted feel of cache looks like.
Yeah, cool.
So what this is doing is it's going to Hub, it's pulling these all out, downloading it from Hub. Hub is, for an image this size, this is fine. My home network is not the world's speediest, but when this is done, how's the weather? It's cold here. Come on, now. It's always the last like 8 megs. It's killing me here, Smalls. Let's go. All right, so I've got MariaDB. I'm gonna do Docker remove the image for the thing I just downloaded. That seems crazy. Oh, because is it running? I guess it is. 90. Got it. Now, and now we'll pull it again. And now it's just much faster. And the reason it's much faster is because it's pulling it out of a local cache. And so it's pulling it over my home network, which is, it's on Wi-Fi, but it's still faster than getting it from the internet. So, that was, I don't know.
Yeah, definitely faster.
20% the time or something.
Yeah. Oh. And that caused you to freeze.
That image.
Uh-oh, we got you back. Okay, we lost you there for a sec, but you're back.
Oh, I'm still here.
You're back. Cool. Yeah, at least in my...
That image is 407 megs, right? So I only pulled it once. And so in terms of my bandwidth cap for my home, or in terms of just overall egress costs, I don't eat that a bunch of times.
Yeah. Yeah, no, it was my old eyes, it was definitely a lot faster.
Yeah.
The old, yeah, that was faster.
We could have timed it, but...
Yeah, cool. Okay, cool. Yeah, guys, check out for things that are coming, new features, what we're working on, what's being launched. Make sure you check out our roadmap. Again, I know I mentioned on here before, but that's public. And it is a true roadmap. Those are the things we are working on. Please feel free to comment, add issues. We definitely, our product managers are in there all the time. We do watch that. That's not us. It's not fake. It's for real. Yeah, 100%. We do have. You have time, Chad? You want to talk about? Now I'm not sure if Manish is saying he knows this. He said, "Okay, question. I came to know Docker new is going to be rootless in a new release in 20 plus.
Yeah.
How's this going to help?"
So when people talk about rootless, it means do you need root permissions to run something? So the old Docker daemon did run as root. So even most applications when you start them as root, so like an init process gets up and starts Nginx. What Nginx will do is it'll drop to a less privileged user, so it's not running as root. So it'll drop to the Nginx user. Docker starts as root, or has started as root. In the future, when it doesn't run as root, what that means is basically your application can only have the privileges of the user that it's running as. And so if you run as root, you have pretty good privileges. You can basically do whatever you want. If you don't run as root, you run as the Nginx user, or you run as Joe Blow, then you really can't do anything. You can't do anything that user can't do. And so you can really scope down what the blast radius of something bad happening is. It's the same thing that we talk about inside the container. Like if you don't have to run as root inside of the container, don't. But when you're running rootless, even if you are running inside the container as root, that container is still running as something that is rootless, which means that even though you're root inside the container, you're not root outside of the container. And so it's going to help with security. And basically just best practice is like, if you don't need it, don't take it, right? So practice privilege, least privilege.
Yeah.
Principle of least privilege.
Yep.
So you don't need the privilege, so don't take it.
Yeah.
So Docker will work just like it does. It just it'll have less privileges than it used to, but you won't notice, generally speaking.
Yeah, I think of it as, I used to tell my kids, not in the context of computer science, but just in general security. I used to be in the military. But anyways, if you only had one house, only one door into your house, right, that surface area of how you can get attacked is only there, right? Same thing with rootless, that blast radius you were talking about, that surface area. If you reduce that as much as possible, number one rule of security is reduce where you can be attacked as much as possible.
So for you, it probably won't actually change much. You probably won't notice the difference. And actually, I think that's the best sort of security. Yeah. Like the kind of security where you didn't really know that things got better. But actually, this is what Docker does, I think, the best. If you think about some of the other pieces, right, there's capabilities, right? So Linux, you can take what root can do and you can chop it up into a bunch of capabilities. So there's network, there's There's time as a capability. NTP is my favorite example. By default, Docker drops the capacity to touch the system clock because very few applications need to touch the system clock. So if you run NTP in a container and you expect that it's going to be able to update your clock, you actually have to add a capability to that container when you run it and say, like, actually, I need you to add the capability to touch the system clock. Because by default, we drop about half of those capabilities out of the box. And if you want to drop others because you want to like really ratchet down what that container can do, you can do that. And so even when you're running in a container, you're more secure than when you're running outside of the container. I think that like NTP inside of a container with the systime is more secure than out, because out that NTP can do anything. In, we drop half and then add the one privilege it needs, and that's less. And I think that's just you get that for free for just using Docker.
Yep.
So I think it's a great way to be secure.
Awesome. Anything else? I think we're kind of at time. We got more questions on my list, but I think that's good. I don't want to.
Yeah. No, thanks.
Wear everybody out.
Thanks, Julio, for coming.
Yeah, thanks, guys.
Thank you, Julio, for coming. We appreciate that. And thanks everyone who is come, whether new or sort of a repeat folks. We love seeing the repeat folks. So thank you very much. And we'll see you same time next week.
Awesome.
Oh, by the way, go download Docker Desktop. I think you should get the Edge version. Sign up for Hub. And go see the new blogs that we just posted, especially the Minecraft blogs. You can go get an Azure, like $200 in Azure creds for free. You can run through the blog, and you too can get Minecraft running for your kids or you, probably you. But that's okay. Like go play some Minecraft.
Yeah, for sure. Cool. All right, guys. Yeah, thanks. Come back again next week. Tweet at us if you got any other questions.
Cheers. See you, Paul.
See y'all.